Hi guys, my name is Ivo Fernandes, I'm a Flutter developer and in this video I'll show you how to improve the performance of your application. So, in the past, when you had too much stuff to show in the screen and the application would become too slow, the solution would be like Google, to show pagination so you can navigate your way to see more results that the device can show you in the screen. Like Google still use this, but that's because in their user experience idea is that you should use these buttons. That's why these buttons are so big and the pagination buttons are so small. So their idea is that you don't actually use the pagination, but a lot of corporate software still use pagination today. I'll show you the Google trends of this. The first infinite scroll solution, I guess, was Facebook newsfeed, but a lot of companies are using a scroll way of navigating through the data. But there are also a lot of companies that still use pagination nowadays. So I will show you how to solve this problem, this infinite scroll problem in Flutter. And for that, I will first show you the steps that the computer needs to do to present the data in your screen. And where are the bottlenecks? Like you have a data layer that will be like the result of a REST API or some data that the user had received in the device. You also have then a build layer where the framework that you are using, depending of its web or mobile, this can be the DOM or can be, for example, for Flutter, is the widget tree. That is the layer that will store all the information that the framework will need to render the stuff to the screen. And here is like the presentation layer where the user will actually do the scroll. So if you want to do an infinite scroll, most of the times you will add stuff to this data layer. Like for example, if you are scrolling and you are reaching the end of the list, you'll create like a HTTP GET to get more data to add here in the end of the list. And will be built to the widget tree and will be scrolled. But what is the problem in this way of acting? Like the bottlenecks of this application are clearly not in the screen. Like if you imagine that this is just a screen, like here you have like only the resolution of the screen and the colors that you will show. So the amount of data will be stored just on like on a GPU with the draw lines that you are doing, and will not have like a big impact on the performance of your application. But here in the data layer, and especially here, is where the bottleneck really is, because like here you will have like all the components and all the information like the colors, the margins, all the stuff that the render system will need to render the stuff to the screen. And you don't want, like most of the times, that these will be built like at once, depending on the size of the list. Like if you imagine like a thousand of rows, you don't want everything to be built at once. So the solution that Android and iPhone came with was something like you'll have a list here where you would start to scroll, but at some point, like the offset of your scroll would be like in a threshold where the device will know that will need to build the next element. So it will be something like we'll remove this element and add another element here. It will go to the data layer, knows that here should be a 9, update this, and then continue the scroll until the end. So I will show you how this is done with Flutter, but before that I will show you the Google Trends of all the solutions that exist to solve this problem. So first was the UICollectionView of iPhone that appeared in 2012. Then the RecyclerView of the Android also appeared. You also have something like that in the web world, like you have a virtual scroll npm package where you can add and take stuff of, of the DOM depending where the scroll position is, and for Flutter you have the Flutter ListView. So now we will go to the Android Studio and I'll show you how you can do this the Flutter ListView in practice. So here I have the Flutter demo application working here in the simulator, and I will clean this demo application. We'll create like a dark theme. Okay, I will delete this widget, and we'll create a home screen where we can navigate to the simple scroll, where I will do something like this solution, where I will build everything and put inside the scroll widget, and this one will be done with the list view. Okay, so let's create the home screen with the 2 buttons. Okay, so cannot be a const. Okay, extend the stateless widget. Okay, the build method, and here I will create the scaffold first, because that's really the root of the app. Create an app bar, title, put a text here calling scroll benchmark. Okay, so let's save this. Okay, it's auto reloaded. Now we'll create the body with the column. Okay, now I'll create the buttons. So the material button, the first material button, that will send to a simple navigation, simple scroll navigation, yeah. So this child will be a simple scroll, and we'll have a color like orange, because it will be kind of slow. And here we will navigate to a different screen. So I will use the navigator to push to a new material page route, yes, with a builder that will have just a context. Okay, and will be the simple scroll widget. Okay, so here I will also pass a size, because I want to test these with different sizes, so we can like increase or decrease to see like different performances. Okay, so this is it's a builder, so it should have a return. Create a new class. Okay, extends stateless widget. here. Okay, this also needs to close the app bar. Close this here. Here I will add the size to the constructor. Create like a constant constructor, yeah, that will receive a size. And let's check here, okay. This is the end of the method, okay. Okay, I'll put just here a margin so it becomes a bit more easy to use. Agent sets margin of 10, okay. Okay, and now I will create this different route. So it's not implemented yet. Okay, let's go back. I'll copy the scaffold here. Okay, it should return this. Here is the simple scroll. Okay, and here will also be a column, yeah, to show the simple scroll stuff. Okay, let's see if this works. Yeah, it's already navigating to a different screen, but it's not showing anything with any size. So here we'll need to generate the list elements. So it's not 100, it's a size to be configurable. Okay, so and here I will create a render widget so I can pass the index and render the stuff to the screen. Okay, so I'll create a widget because I want to be able to do like a print so we can see here in the console what is happening and what is happening when the screen is blocked. Like, because if you increase this size too much, at some point Flutter will be building all the widgets to put on a widget tree, and the stuff will become slow. Yeah. So okay, let's set the index here on the constructor. Yes. Okay, this is the final index. This is a constant. Okay. Okay, and here we'll print the index to the screen. Okay. So it's overflowing because it's not inside a single child scroll view, so you cannot scroll it yet. We should add a single child scroll view here. Single child scroll view, yes. And okay, at reload, we cannot scroll here. I'll show you why, but we already can scroll here. Okay, to be able to scroll like in a normal application, we will put this text inside a container. I'll put a color here so you can see why the scroll doesn't work in the middle of the screen. That's why the column is not being filled, like the column ends like here. And all this part is like, it's just scaffold. So the scaffold is not being filled with this column. And to solve this problem, I will add here on the container width. So I'll put double. max finite, okay, and now you can scroll. Okay, so now we are ready to test the performance. I will take the color out. We don't need it anymore. Okay, if you click here, you go there. I will also print here like that we are building the index that we are building. Okay, this will also affect a bit the performance, but for now it looks like it's working fine. So for 100 elements you can use this approach, but like if you increment here like 1000 or more, it will start to become slow, because like you see, you click here, the console starts to work, and it's because like Flutter is building all these widgets, but only when it's ready that you actually do the navigation. So I will increase a bit more so you can see a bit more clearly. Okay, so you see it's building all this stuff, and only when it reaches the end that it starts to be like usable. And it's not really that responsive, like it's too much stuff and it's not working that well. So this approach for a lot of elements doesn't work that well, and we will try to use this one with the ListView. Okay, so for that we will create a new button here that instead of the simple scroll will be a recycle scroll. Will be green because we want it to be fast. Oops. Okay. Recycle scroll widget. Okay. Okay, I will copy this class because we'll also need a scaffold. It will be faster. Recycle scroll widget, okay, instead of simple. Okay, so now here in the body, what should we do? It will be even easier to do it, like you just need to use a ListView builder. This builder receives a context and an index, and here you will do the creation of the render widget. So it will return here, and I will limit the item count to the size that it's passed. Okay. So the auto didn't work because forgot to close the scaffold. Okay. So now we have this slow simple scroll here, and when I click on the recycle, it will be much faster. Like I click here, and this immediate, it comes immediately to the screen, but it's only rendering the first 49 elements, you see. And when you scroll, it starts building the rest. Like it will build the rest as you scroll. You can also like put a breakpoint here and see how Flutter did the implementation of this technique to only build the elements that you need to have. Like, for example, now it created elements until the 87 index. That is like 15 after what we are. And now if we scroll more, you see it's stopped here. And you can see like how the ListView was implemented to do this stuff. Like, so this is the build method of the ListView, and you have all the widgets that were created by Flutter, you can notice here that you have an advanced here. That's where the Flutter implementation detects that you should go to a different, that should build a different widget, like the next widget, and it's looking to the scroll offset and yeah, doing the calculation to know that you are close enough to the position where when you need more stuff. It also happens like to build, if you scroll too much to the bottom, it will like destroy the elements below. You can see that if you scroll like a lot to the bottom and then you scroll up again, you see it will also build the elements of the beginning of the list. So it never keeps too much stuff in memory. It avoids this bottleneck, that is to create too much stuff. And the only thing that you'll need to solve is this data layer. Like for example, if it's really too much data, like at some point you may have a bottleneck here, and we'll need to put stuff in the local storage like SQLite or some Sandbast or another NoSQL database, or even don't store the stuff and request the server again when you need more data. But this data layer is much less heavy in the memory than this build layer. So like with this list view, you can solve like most of the problems that you will have in performance in applications doing scroll. So I hope you enjoyed the video and the presentation. If you like it, hit the like button, subscribe to the channel so I can know that I should do more videos like this one, and I see you next time.